Hi there, and thanks for attending. So let's get right into it. My name is Kenneth, as he's just told you. I'm Danish, so we used to be the most happy people in the world. Unfortunately, we are no longer. But our plugs look very similar to the ones in Israel. So that's pretty amazing, I think. So I work for a company called Intel. You might have heard about them. We do chips, we do data centers, we do all kinds of cool things. And we also work on the web. So I work on Chrome itself. I also work on standards in the W3C and trying to figure out like how is the web going to look in the future and how can we affect it in the positive way, make it easier for web developers to create amazing experiences on the web. I'm also a Google developer expert, so I want to say thank you for Google for bringing me here. It's super awesome to be here in Israel. And let's get right into it. So what are smart devices? And what makes a thing smart? Well, if you think about it, if I have to turn on the light in this room and have to pull out my phone, unlock it, find that app, where is it, wait for the app to launch, and then find the right lamp and click, then that's not smart. We want things to have, we want to solve real issues. And we want things to be there when you need them. Not something I need to like unlock my phone to find. And we want to have low friction. We don't want like all these problems. It should be easy. I don't want to download an app for simple tasks. And this is where the web excels. People, they just want to do things and they want to do it now, right now. And think about the future. People talking about like Internet of Things, ambient computing, everything is going to be connected. But what if you have like around 100 different devices in your home, your lamps, your TV, your toaster, then that won't scale to 100 different apps on your phone because you cannot find that app you need when you need it. It becomes a bit like Windows. All these different icons, where is that icon I was looking for? Very difficult. Unfortunately, the same is happening to our phones. We get all these different apps installed. It becomes complicated. Too many icons. Lack of overview. And then we get these updates for this app I installed maybe 2 years ago and I haven't used ever since. Taking up my data plan. That's not really what I want. If we look at these smart devices, we can categorize them into 3 groups. There are apps or services or devices we use every day, like turn on the light. There are services we use once in a while, like maybe change the temperature of my fridge. And there are some we use like maybe once a year or very, very rarely. It could be like me traveling to San Francisco, I want to pay for a parking meter, and I need an app for that. But I'm not going back maybe for 2 years, so why do I really need to download 100 megabytes for that? It's kind of annoying. So maybe there's a better model. We want the low friction and we want the ease of use. And everyone, all of you like our web developers, we get this thing. Everything on the web is just a URL away. But in order for this to really work, the web needs to be fast. And there's like a lot of good things going on in the web lately. There's been a lot of focus on speed, especially HTTP2 server push, service work on something called a purple pattern. So we've really been working on, especially I work with Chrome, as I said before, we've been working on making the web really fast and making it fast by default. So we have a new thing called service workers. Some of you might have attended the other talk in the other room today, so you know all about that. But it's basically like a proxy server sitting between the internet and your device. So if you're not online and you have things stored in your service worker, it can still work offline because it will have all the resources. And I don't know what's going on here. Okay, there we go. So the cool thing is that every time you try to like fetch a resource on the internet, it will ask your service worker, what do you want to do? The service worker might say, well, you're offline, so maybe I should take it from the cache. This allows you to create like amazing experiences. Like for instance, if you have something like Netflix, maybe in the future where you like save a couple of movies. And when you save those 3 movies and you're offline, it might be able to generate a list of only those 3 movies available to you. So this means that the dinosaur is becoming a thing of the past. The purple pattern is a new model from Google, where they try to figure out how can we use all these new exciting features and make it fast by default. because they have a goal that every app should launch in about a second. Maybe on 3D, maybe 3 seconds is the max, because otherwise, people, they just don't care. And the idea is that you push all the critical resources for your initial view. Keep in mind that this view might not be the same always, because the web has deep links. I might have www.mysite.com/home or www.mysite.home/images, something else, and it might show a different view. So you just get all those resources you need to show that initial view. You show it on screen, you render it, and then in the background, you can fetch what you need for maybe when the user is going to click somewhere else inside your app, and then lazy load those resources. So this is a really nice way where the server can try to look what's available, look what you're needing for your current view, and only give you those resources. And this is one of the cool things about HTTP 2 push. So what you're seeing on the image here is that there's some shared dependency between view A and view B. Both might use a bottom. So you might have a bottom element. And that when you already visited view B, you already have that in your cache. So when you visit view A, you don't need to download that again. The server can figure that out itself and auto-bundle all your dependencies together. So this is something that they're working on, and they're also working with the Angular team at Google to figure out how to integrate that in Angular. So the base takeaway here is that the web is up to task for creating amazing experiences. So the web can work offline, it can be fast, and it can be responsive. So let's just take a look at how that looks if the internet is with us. Here we see an app. It launches immediately and looks just like a native app. Everything is smooth and fast. And people ask, but that can't be the web because I don't see an address bar. It's fast. There's an icon on the home screen. Isn't that a native app? No, there's an experience we call progressive web apps. And if you haven't heard about that, I really encourage you to check that out. So the web is really great for these one-time usages. So I was talking about before, flying to San Francisco, trying to pay for parking, need an app for that. It's a one-time experience. So the web has this really low friction. Type in the URL, and there you are. They can also be handy whenever you need it. With progressive web apps, you can have this icon added to your home screen, and it's always there if you use it on a daily basis, like to turn on the light. And that is really important in some markets. If you take a market like India, people have never used desktop computers before. They're not so good at maybe there's a lot of people that don't even know how to type. So it could be pretty difficult to go on Google and search for something or type in a URL. But maybe some of their friends just sent them over WhatsApp a link, they click on it, and they add it to their home screen. And it's always available. And also, there's all the clutters away. You don't have the address bar, which might be confusing to some users. Well, is this part of the app, or is it the browser? What is the browser? And you can remove all of that with progressive web apps to make it really look like a native app. But one of the really important part about the web is that it's safe. It's safe by default. Because everything lives inside a sandbox. But we were talking about smart devices here, so most of these devices kind of live outside of the sandbox. So how do we deal with that? And the fact is that you can do that on the web. Let's see if this connection is better. So, one thing to keep in mind is I'm going to talk about two technologies in a moment. I'm going to talk about Bluetooth and USB. One thing to keep in mind is that users and companies normally don't care about technologies. It's not like USB versus Bluetooth. Choose a technology that serves your purpose. So let's start about looking at Bluetooth. So what are the advantages of Bluetooth? Bluetooth is widely used. It doesn't use a lot of energy, so if you have a device which is battery powered, it's really nice. And it's wireless. That is one of the major advantages of Bluetooth. It works without a wire. It's also relatively cheap, easy to use, and it has some beacon functionality built in. And I'll get back to that in a moment. Some of the disadvantages could be security. This is basically radio waves. So you need to think about what you're sending. If it's highly sensitive, maybe you should use some kind of encryption. It's also not powered, so the device will need to be powered somehow. for instance, by a battery or by actually plugging it in somewhere. And because it's like wave-based protocol, there can be problems with stability and speed, especially like concrete walls, interference from other like Wi-Fi stations, radio towers, etc. So let's take a look at how it works today with Web Bluetooth. Here you see a guy connecting to the light bulb in the middle. He just selects the device on his screen, and he's able to actually change the color. No wires used, just using a regular website. This is pretty amazing, I think. Web Bluetooth is a relatively new standard. It has been promoted by Google, though other companies working on browsers are starting to look at it as well. It's based on Bluetooth 4. So if you know anything about Bluetooth, there's something which is called classical Bluetooth, and there's a new version which is normally people call Bluetooth Low Energy. It comes with something called the GATT protocol. The API itself is very modern and is easy to use, so it uses promises and something called typed arrays. It doesn't support classic mode. It only works as a central. It means the device itself, like your phone, cannot be a Bluetooth device, a peripheral. It can only interact with peripherals. So support is working in Chrome at the moment, and they're working on bringing this to all their major platforms. Here's a website where you can check the current status. We talked about security a few moments ago. If you want to use Web Bluetooth, you need to use HTTPS. This means that it's a secure encrypted connection. In order for you to stay safe on the web and not just connecting to random devices while like browsing and clicking on links, when connecting to a device, a Bluetooth device, there needs to be a user interaction. You need to click on something. It will need to show a dialogue, and then you'll need to connect. This is a security measure. So it looks like this. Here I'm connecting to a polar heart rate belt. I click on the screen, it can show a dialogue, I can select my device, and click pair, and there you go. It can measure my heart rate. See, this is not live, but it works pretty well. It's super cool and super easy to use. So how does it work? I don't intend you to really understand the code here in details, but just to show you how easy it is. The first thing you do is that you request a device, and you can add some kind of filter, because there might be many different devices around you. In this first example, I just asked for any device supporting battery service, which should be basically every Bluetooth device. Then, if my connection succeeds, I can do something. If not, I'm using promises here, I can catch an error and handle that. Some devices might have very specific like UUIDs, and you can connect and filter with those as well. One of the things to keep in mind here is that you might have two different devices that act very similar. So I might have a device that has like battery service, and I have another device also having a battery service, but my second device also supports, let's say, a heart rate monitor service. So if I want to create an app where I could connect and show like the battery status of both of them, but in the case that there is like a heart rate monitor available, I want to use that, I need to add it as an optional service. So that's why you see the optional services here. This is something I just want you to keep in mind if you ever work with this. Bluetooth GATT is called a generic attribute profile, defines how Bluetooth Low Energy works. It looks something like this. You have a profile with services inside, and inside you have characteristics. If you work with JavaScript, which you obviously all have, you can think of a service as something like an object. And characteristics are kind of like properties. That's kind of nice. One thing, so like characteristic could be like a Boolean or a number, but as many of these devices are Bluetooth and they're like, you want to like compress things as much because you're sending it over the air, it's very common that a characteristic could be like a byte array, actually including multiple values. When I get my device, I connect to the GATT service, and from the GATT service, I can connect and listen to my characteristics. So here I already connected, I got the service back, and I ask for the battery level characteristic. So think of this as a property. And then I can call read value. Read value, because this is a binary protocol, returns what's called a data view. So in JavaScript or ECMAScript 2015, there's something called typed arrays. It's also used a lot in WebGL. So this allows me, I know that this is just an unsigned integer, a byte, so it's 8-bit. That's why I call get uint 8. So you kind of need to know like how to read these values. Writing is just as easy. Instead of calling like read value, I would call write value, and I'll give you the value, which has to be a typed array that I want to write to. And it works really simple. But sometimes you have some of these values, they might change. It might be something like a temperature sensor. So we use the same thing as on the web. You have DOM events. So when you get the characteristic, you can add an event listener. So here I'm adding an event listener, which always call characteristic value changed, and add a callback. So every time this value will change, like my heart rate, I can print it to the screen or do something with it. Very, very easy. But how do I discover all these devices around me? Bluetooth comes with something called, now I forgot, like announcement. You can announce devices. But it's not defined in the standard, like how do I share a URL? So Google, they've developed a standard called Eddystone on top of Bluetooth advertisement, which tells you like, hey, this is a URL. That this refers to an app on the web. That is called Eddystone. And for the URL part, it's normally called physical web. That's just a part of Eddystone. So we'll show up something like this. If you have an Android device and you've enabled Google Nearby or Android Nearby, for instance, this is an example from London where they're using it at the bus stop. So you just pull out your phone. It will show you that there are like physical websites nearby. And you can click on the one for the bus, like ETA, estimated time of arrival for this bus. If I click, it will open up this progressive web app. And I have all my info there. It's really, really nice. And of course, like this works even better when you're connecting to devices. This is just a beacon functionality. They're not interacting with the device itself. It's just like sharing a URL. But you can actually share like a URL to an app where you can interact with it over Bluetooth. And I think that is super, super powerful. To get started with Web Bluetooth, here's the URL. The links will be shared later, so you can go and have a look yourself. So let's look at USB. This is the other standard. USB is also widely used, like Bluetooth. It's very cheap. It's cabled, so it means it's more secure. There's nothing in the air to intercept it. It's also much faster and very stable. And one of the cool things is that with USB, you can actually power devices. So they don't need to have like an external power supply. One of the disadvantages you can say is it's cable. As I said before, it really depends on your use case, whether you need to choose one or the other. Maybe you have legacy hardware that only works over USB, so you have to use USB. USB also has no radio interference. And the cool thing, especially like in companies, like if you have a factory and you really want like a web experience to control your machinery, you might not want that over Bluetooth because there might be a competitor outside trying to connect to it and messing up your machines. But with USB, it's a physical connection, so you could have it behind a lock. So really, really, really think about these different use cases. And as I said, both technologies work very well together. So here I have an example I did at home. I created my own IoT device. You see it's currently unplugged. So I talked about USB is powering it. So I'm plugging in. It takes around 5 seconds to start. So I'm looking at my screen. You'll see the light turn on in a few minutes. Yeah, there you go. It finds the device. If you click on it, it will launch that website. So I'm clicking on it. And this is really cool because I made this device that actually runs JavaScript. So I have like a JavaScript editor in my browser. I'm also showing that I have the web USB permission. If I now click on run, so you see there's a bit of JavaScript. It's reading the temperature. So you see there's a temperature sensor there. Nothing is happening currently. Now if I press on run, it will start showing the temperature. So there you go. You can see the temperature. And just to show that this is live, I'm actually checking out another sample. It's called RGB, and running that as well. So you see now it's changing the color of the RGB, all using the web and a USB cable. I find it pretty, pretty powerful. USB has 3 different modes. I'm just going to skip over them because we don't have so much time. Something called bulk, interrupt, and isochronous. Bulk is the fastest, but there's no guaranteed timing. So this is what printers and serial connections use. Interrupts, they have like a maximum latency. So this is good for when it need to be delivered, like a mouse and keyboard. You don't want to type on a keyboard and wait 5 minutes before it's to show up on the screen. It has to happen immediately. And if for something like a webcam, you use isochronous, you might lose packages, but you just try to send as fast as possible. With USB, you can add a few extra headers for extra security and restrictions. So this allows, these are optional, but they allow you to, like the bootstrapping dialog you saw before, like to select the website, that will have to be an additional header. Like this I'm showing currently. So there's a few issues with Bluetooth now with USB, especially if you use a serial connection, because your host OS might try to install a driver for it. So I'm just listing this on the slide and just quickly going over it. Connecting to a USB device is very similar than to web USB. I'm showing it now with the new async await, so it's slightly easier to read. You request a device, you open it, you select the configuration. This is just how USB works. And then you can have these like control transfers, like do something, and you can, I'm doing here a transfer in to read some data. So with USB, the computer, your phone, or whatever, is always the master, and your device's peripherals serve as kind of slaves. So you tell them what to do. You read, you ask. So this currently works in Chrome on Windows, Linux, and Mac, with a few caveats. And people are telling me it also works on Android, but I haven't tried that myself. Here's a link where you can find out more information about Bluetooth. Wow. I know this is a lot, and I only have half an hour, so this is a bit quick, but I'll make sure to share the slides later. I told you the web is really, really good for these one-time interactions. But there's a lot of company out there that track things. Because like your companies, you want to track your packages, your storage, like what products do we have, etc. And that's really, really cool. But people usually use like something like NFC or barcodes for doing those things. Maybe using this this Bluetooth beacon I showed you before is the right solution. Maybe even NFC tags, but sometimes QR codes and barcodes work pretty well because they're cheap and you can print them on a printer. So in Chrome, we're actually working on enabling these things as well. So behind the flag, there's a new API called shape detection. It's called shape detection because it works for barcodes, but also other things like detecting faces in a picture or in a video stream. Really, really advanced things. So I just wanted to show you that you can do these things on the web today. If you need to do something with NFC tags, I am actually one of the editors of the web NFC spec. It's also behind the flag in Chrome. So you can interact with NFC tags and devices. So here I'm showing like how to push data to an NFC tag. I'm just writing a URL to a tag. If you don't know NFC, you have like active devices, and you have like passive devices like tags. If I put the tag close to my phone, the active device will actually send out an electric current that will power the tag, which allows you to read the values on it and write to it at the same time. Here I'm showing an example where, I said it happens at the same time. So here I'm showing an example where I try to figure out it's empty. If it's empty, I write my name to it, canf. If not, I call this function called process messages, which is going to read like hello canf. Yeah, and I have 5 minutes, so this is going to be quick. And it's pretty cool. Even the inventor of the web, Tim Berners-Lee, was excited. And I have a small video to show you how cool this is. So here I wrote a small app. It's a progressive web app. It's all web technology. Now I'm writing milk because I want to write that to a tag. Because I want to place these tags around my home. Every time I need to buy milk, I just tap this thing. So now I wrote milk, and just to see that it works, I tap it again, and yes, it got milk. Now I'm trying to write something else. So like cocoa. Unfortunately, I couldn't get it to connect correctly because you have to find where the NFC reader is. So just do it with my hand. There we go. Now it wrote cocoa. So I already configured these others, so I can just add different tasks and products at home. To just show you how easy this is and how cool it is for users. But sometimes, woo, we still have a few extra seconds if people want. I just want to show you some extra things because we're working on sensors. So we worked on a lot of different sensor APIs for the web, like gyroscope, magnetometer, accelerometer, ambient light sensor, orientation sensor, etc. If you're new to sensors, I don't know how they all correlate. I wrote a spec called the Motion Sensors Explainer, which explains like how all these sensors work together, how you can do fusion sensors, etc. So I just wanted to show you an example of how to use this. So this is an example where I connect over web USB, I have a sample app, I connect to this USB thing and expose them as sensors. So you can do like really, really cool things. And even with my IoT device, I did exactly the same, using the exact same API. And now the cool thing is that this is the device I wrote in JavaScript on my device. It's around like 68 lines to actually read these values with the generic Sense API, expose them over Bluetooth. And I have around like, I think like 71 lines of code for reading on the web app and actually doing these things. So if you're interested in sensors, you should definitely check out the generic Sensor API. So in summary, the web is ready for all these nice experiences. It's effortless to connect to Bluetooth and USB, currently only in Chrome, but we're expecting other browser vendors to follow suit. NFC support barcode readers is work in progress. It's behind a flag in Chrome today, so you can experience at home. And generic sensors are also being exposed to the web, so expect a lot of cool things to happen, especially in the area of web VR, where you definitely want to interact with different sensors, maybe a sword that will show up in your game and stuff like that. So the web is ready. Let's build the future together. Thank you for listening.